All right. So, oh, okay. There's another person. Gina is here. Good. Yeah, now on the spotlight in my video. Okay. So we're just gonna work some problems. I wanted to ask: should we do 18 or 19 stuff? I was thinking 18 because you have the quiz. Can we do 18? Yes, most definitely. I was going to do some of the book problems. Anastasia's here. I was going to do, oh, wait, before I forget, here's the sign in thingy. Sign in, Google Docs. Here we go. Okay. Let me go find some 18 suggested problems. Shoot, there it is. Go do this one. It's one of the suggested ones. Okay. Over here. This. Yeah, that's what I wanted. Okay. We'll do this first. It says delta H naught is 177.8 kilojoules per mole. Delta S naught is 160.5 joules per mole Kelvin. We want to know the partial pressure of CO2 at 25 degrees Celsius and 800 degrees Celsius. Okay. Hopefully you have that written down some way, shape, or form. If not, I have the gist of it right here. I don't know why it's so zoomed out today. You usually can't see my name thing up there, but it's whatever. All right. Oh, so we want to know that at equilibrium. So we want these. Ooh. At equilibrium. Okay. So, all right. If doing with equilibrium stuff, we probably want to know what K is. So what's K in this case? What's my K expression? Some of you, we did a similar example last time. So CO2, yeah, right. It's the pressure of CO2, right? Okay. Right. Those two are solid, so it don't matter. So my K just boils down to my partial pressure of CO2. Okay. So figuring out that just turns into me figuring out what K is. Okay. And right, he'll give you all these. So, and you'll go look at your equation sheet and you'll see what delta G naught equals delta H minus T delta S. And then you'll also see delta G naught equals negative RT natural log of K, right? And then it's just plug and chug, right? We plug it in to get delta G, and then we can plug it in there to get our K. So let's do that. So delta G equals my 177.8 kilojoules per mole minus my T, but in Kelvin, right? So 298 Kelvin, or now space, times my 160.5 moles Kelvin over joules. Is that right? Did I do this right? Need to convert, correct, right? I need this in either that in kilojoules or that in joules. I'm just going to convert this to kilojoules, so I'll do 10 to the negative 3. Kilojoules. Okay, delta G naught. I brought my calculator here this time. Where did I put it? Oh, here it is. Oops, negative 3. So I get 1,000 or 129. How many 6 do I want? 4. So I get 30.0 kilojoules per mole. Right now, I throw it into this guy. So now I do my. So now I know that 130.0 kilojoules per mole equals. So R in this case is going to be our 8.314 joules per mole Kelvin. Right, that'll be given, and then again we need our units to match. So I'm just going to make that kilojoules. So negative 8.314 times 10 to the negative 3 times my 298 again, my natural log of K. Right. Divide by these two to get my natural log of K. So I get negative 52.46. And so K, just do everything to the E. K is 1.649 times 10 to the negative 23rd, which is also our partial pressure CO2. Make sense? Yes. Okay. Why don't you find me the pressure at 800 degrees Celsius? So go do this again, but do it at 800. How do we know where to put the times 10 to the negative 3, and do we put it only once? So here, so what I'm doing is I'm converting from joules to kilojoules, right? So this was originally, this was 8.314 joules per mole Kelvin. So I needed it in kilojoules. So I put 8.314 times 10, right, to get from joules to kilojoules. Here, let me do it this way. So 8.314 joules per mole Kelvin. And so to get from joules to kilojoules, there are 1,000 joules for every 1 kilojoule, right? And then this is my times 10 to the negative 3, right? Same thing happened here. I needed to convert that to kilojoules, so I did 160.5 times 10 to the negative 3 moles Kelvin per kilojoule. Right, so this is 8.314 times 10 to the negative 3 kilojoules per mole Kelvin. Okay, cool. So yeah, do that. I'm just doing that to make my units match. You're welcome. Yep, I got it. I confirm as well. So where should I put that? This is at 25. Oh man, 25 degrees Celsius, and at 800 degrees Celsius, you got the K was 0.53, and the pressure of, which is also pressure CO2. Cool. Make sense? Yes. Anastasia, did you get the same thing? Yes. Awesome. Cool. Okay, so that was that. Another thing I would like to point out and talk about, remind you of, is that, let me erase this. So if you just, so here he asked you for K at a particular point. So I just want to remind you that another type of question he could ask is if he either, he either gives you these or has you calculate them from your enthalpy of formation, right? And then he asks, at what temperature does this reaction become spontaneous? Oh. And we'll just assume it's at the equilibrium time, so we only have to concern ourselves with our delta G naught. We're only going to look at this. Okay. Does anyone remember what I need to do with this to get that temperature to become spontaneous at? Saying no answers.
What do you mean by what you need to do with it?
So like, how do I use this to get that temperature? Does that, maybe that makes more sense?
So the delta G has to be negative.
Mm-hmm.
So if your delta H and delta S are positive, right, then doesn't your temperature have to be high?
Yeah.
Okay.
So that's kind of what I'm asking. So you're thinking the right thing. Okay. So delta, you want delta G to be negative, right? When delta G naught is negative, so less than 0. Sorry, brain fart. It's spontaneous. And we have a positive, we have delta H that is positive, and then delta S that is negative, or positive, it's also positive. So you know that that means that at high temperatures, high temps, it's spontaneous. Okay, that's kind of what I'm asking. That'll help us later. Question now is, what do you mean by high temp? Right, high is relative, so what the heck does that mean? So there's a point, right? The point that I was asking you about, this is not far off. So we need to know when it goes from spontaneous to non-spontaneous, right? right? And it's non-spontaneous when delta G is greater than 0. It's non-spontaneous. Hopefully y'all can, yeah. Okay, so if it's non-spontaneous when it's positive, spontaneous when it's negative, so it flips at 0. So that's this temperature. The temperature becomes spontaneous. I think I put temperature. Does this? At what temperature does this reaction become spontaneous? Okay, I did that right. But anyway, see what I mean? So it becomes spontaneous at the point when delta G is, when it goes from positive to negative, which is at 0. So I would take this, my equation, and solve for when delta G was equal to 0. Right, plug in my delta H, 177.8 kilojoules per mole minus T, I don't know, times, and again, I'm going to make my units match. So 160.5 times 10 to the negative 3 kilojoules per mole Kelvin. All right, then I solve for my temperature, right? Add this to the other side and then divide by my H, or divide by my S. So what I'm saying is, so I have 177.8 kilojoules per mole equals T times 160.5 10 to the negative 3 moles Kelvin over kilojoules. So I get my temperature, it's just those two, this divided by that. And I see that 177.8 times 177.8, 160.5 times 10 to the negative 3. So I get 110, call it 8 Kelvin. Right, so that's the temperature. Oh yeah. Good job, Leah. I didn't look up, so you may have gotten that before me. But that's the temperature becomes spontaneous. And this part, this says, oh, at above this one, it'll be spontaneous. So when it says high temp, this is the temp it's referring to when it's 0. That may be confusing, but this is the main section you'd have to worry about, because I think we did a PowerPoint example like this, where it's like, at what temperature does this reaction become spontaneous? You basically solve this equation when delta G is 0 for temperature, which we did, and now we got, that's the temperature becomes spontaneous at. Does that make sense? Yes, cool. Any questions on this? No, yes. Awesome. Okay, let me see. Try to go find just another example. Oh, excuse me. Unless anyone else has something they would like to do, I'll find this another chapter 18 example. Okay. here. All right. This is another example from your book. It's kind of just more plug and chug, but you know, that's what these problems are. Here. Let me write the equations over here that you'll need. Unless you probably already found them and you're already doing this. And if you are, that's great. If not, that's okay. Delta G plus delta G naught plus RT natural log Q. Then R is 8.314 joules per mole Kelvin. Okay, hopefully you wrote that. Maybe. I wrote the gist of it over here, if you could read it. Think you can do this? Does anyone not know what to do? I'm thinking all of you are working on this, so just let me know if you get stuck or have a question. Is negative 24.6. Yeah. Negative 133. Yeah, cool. That's what I got. Kilojoules? Yeah, kilojoules. Not too bad, right? Or lead and anesthesia, did you get the same thing? Yes. Cool. One more. Yes, awesome. Okay. So we'll do, let me see if I have another one. I'm gonna do, oh, let me, can I try out a poll real fast? Maybe. I want to do this on maybe the test review to maybe do a poll either to get people to see when people are done with the question and or to see what questions we should do. So kind of do it Jeopardy like. Oh God. Hold on. I guess it could be anonymous test. Did it work? Hold on. I'm testing this poll. Let me know if you can see that. Oh. Did it work? Not for me. I can't see it. No. Okay. Awesome. Never mind then. Don't worry about it. All right. I'll figure that out later. Are all of you using laptops? Let me ask that while I'm looking for another thing to do. Yes. No. Okay. Interesting. I'll figure that out later. Let's see. We could do something from chapter 19 that involves delta G. Maybe that'll. No, let's do another 18 one actually. Actually, let's do this 19 one. It's okay if I do a 19 one. It has delta G in it. Yes. Yes. Awesome. Because that's the only other question I have, or that I'm ready to do. Bam. Okay. Here we go. Be interesting to see what happens on the recording for that poll. Probably nothing. Share. This one. I guess. Down some equations on need. Ew. Hold on, let me make sure I write this down right. I think I forgot negative sign. Yeah, I did. Okay, delta G naught is negative. Okay, hopefully you got it. I wrote down the gist of it over here as usual. Oh, I guess I should leave it up there so you can see the delta G's. Let me do that. All right, so hopefully you could get delta G no problem. So why don't you go ahead and tell me what you get for that? For delta G naught. How do we find the amount of electrons transferred? Ooh, good question. So you have okay, I'm gonna stop sharing this now. So right, this is, hopefully you checked it. This is our redox. Well, you didn't check it. I probably didn't imply you should have, but this is our redox reaction, right? So we have to do what we were doing when we were balancing it, right? So we split it. So I split it into my two things. So I do my, I'm just gonna do NH3 plus NH3 goes to N2. I guess we can keep the coefficients. And then we have our other guy. Our 3 oxygens goes to our 6 H2Os. All right, so it's like we're normally balancing it. So we take our, do our thing, balance the non-hydrogens. So that one's good. Got 4 Ns. Then we balance the O's with water. There are none, so don't do anything. Then we balance our H's with H plus. So there are 12 on this side, none on this side. So I add 12 H plus over there. Right? And then I balance the charges. So now I have positive 12 over here, 0 over there. So I need 12 electrons on that side. Right? Still got to check the other one though. So my balance your non-hydrogen is oxygens. You don't have any in there. Balance your oxygens. You have 6. You have 6 on that side, 6 on that side, so you're good. Now you balance your H's. So we have 12 over there, so I need 12 over here. So I'm gonna lower it. 3O2 goes to, I need that 12 H plus on this side. So 6H2O. Then again, similar thing, have plus 12 over here, 0 over there. So I add my 12E minus. Right? And then we would add these two things together because they're the same. So here's the number of electrons transferred, 12. No problem. Okay, so whenever y'all are ready, you can give me delta G and then your E cell. Can I see? Oh, do you guys need Faraday's constant? Oh, it's 9. what is the N the moles of again? It's the moles of your electrons transferred. So like in this example, to get N, we needed to figure out how many electrons are being swapped in our redox reaction. So in this case, there are 12. Or yeah, he said in class, N is the number of electrons you cancel. Same thing. So when we add these reactions together, we cancel 12 electrons. So N for us is 12. Could you do this one all the way out? I'm a little stuck. Oh, I didn't see that N equals 12. Can you work it out? Yes. Okay. Is this workout for how to get N okay? Like, can I? Oh, camera. Okay. Can I? Yes. Okay. So we're good on N. So here's N. I'm gonna write that up here. I'll write it down here. We'll write it down here with our F. So we know N is 12. And no, okay, that's fine. Okay. Okay, let me show you what. So I gave you the delta G of formation values. Let me share it with you again, just to be safe. Please, computer, thank you. Oh, Anastasia dropped out. Oh no, she can watch this, the video. Let me share this. So here's the delta G's I gave you. And then so you put, so delta G naught is our products minus reactants. So with their coefficients, so N2 is 0, I'm gonna write it still just to be safe. So 2 times my N2G, 0 plus 6 times the G for H2O, which is negative 237.2. Right, products minus my reactants, so 4 times my NH3, which is negative 16.6, plus 3 times my oxygen, which is 0. Right, again, just writing it to be safe. So delta G naught is my, oh, I did it already. Let me stop. You can stop sharing this so you can see it. So yeah, where's my calculator? I think I did it already. I got negative 1,356.8 kilojoules per mole. So yeah, so we got that. Okay, everyone okay with that? Yep. All right, cool. Get rid of this then. All right, now we need to use our E cell formula to get our delta G, or not to get delta G, to get E cell. Okay, so now we know what delta G is now, so plug it in there. So negative 1356.8 kilojoules per mole equals negative what was it? Oh, negative N, which is our 12, right? N is 12. Okay, Faraday's constant. Here again, we have that issue of this is in joules, right? And G is in kilojoules, right? Swap it whichever way you want. I'm going to just make this kilojoules. So that's going to be 96.5 kilojoules, or hopefully it's in kilojoules. I'm not going to write this down wrong. Volts per mole, right? And that's going to be my E cell standard. Okay. So divide by these two. So E of my cell, not paying stages back. So E of my cell is what? Sorry, my off was. No problem, Anastasia. You can still watch this back on YouTube, and I'll put, because I usually put tags in the description, so you just skip to this question. It'll all be good. Okay. I got, okay, my calculator. 12 times 9, 6.5. So I got my E cell being 1.17. Just for consistency. Ooh. Oh, that was bad. Up volts. No naked numbers, volts. Naked numbers are bad. It's also in volts. They are greatly appreciated. Awesome. Oh, are you talking about my videos? I did see that one person liked it, and that was nice. I don't know who did, but yeah. Did that make sense? Let me make sure. Those are the right numbers. Is this 83? Yep. Make sense? Right, don't forget, pay attention to your units. Right, again, this is where you could get tripped up if you forget that your Faraday's constant's in joules and that delta G is in kilojoules. Any questions on this? You're welcome. Yeah, it's about that time. So if you don't have anything you want to ask me right now, we can be done. I know I'm thinking I'm doing it on Sunday, even though it's Easter weekend. I'll be available. I'm not doing anything fancy. All right, you're welcome, everyone. I'll see y'all later. No problem. No problem.